Hello and welcome. In this lesson, we would discuss the solution of the challenge problem which we talked about in the previous lesson. If you haven't taken time out to find the solution, I would suggest you to give a strong thought on what solution should be. This would help you to understand the concepts and the design of MapReduce framework in a better way. So our map would receive the input record 1, to be or not to be. Here 1 signifies the byte offset which is supplied by Hadoop. So what our map algorithm would do is that it would tokenize the input line into words and for every word emit word, 1 as a key value pair. So output would be 2, 1, b, 1, or, 1, not, 1, 2, 1, and b, 1. 1 would signify that the word has been encountered once. This would be sorted on the basis of key, that is, word in this case. So now keys and values arrange themselves in the alphabetic order. For reducer processing, the key value pair would be changed to key and list of values. So now it would look something like this. Now you can see that the word has occurrences following it. The shuffle and sort step, which is provided by Hadoop, has put together the keys and their values. And so the values put together have started to make sense. So now the reducer would call the reduce method once per key. And in the method, it would iterate over the values of each key and sum it up to produce the result. Please note that every time you would see the same structure of the reducer. It would have initialization, followed by iterations of values over the key, and the function ends with the output of key and value. We can design reducer to emit 0, 1 or more key value outputs for each time it is called for a key. Let us look again and see through a simulation how this would look like in case where many maps are processing in parallel. Let us consider the case of two maps running in parallel and having input as 1 to be or and 10 not to be, where 1 and 10 are the byte offsets from the start of the file. Please note that in the real world, there would be many maps and inputs would be huge, of 64 MB range. This is a simulation, so we are talking very small inputs to understand the concepts. As we have already seen, map would tokenize the line record into words and emit 1 as value. The output would be as shown. These would be merged and sorted. These would be fed into reducer to produce the output. The power of parallelism can and should be harnessed at reduce phase as well. Let us take a look at a case with two reducers. In this case, the reducer input would be partitioned keeping two things in mind. First, that the value of all the keys goes to the same reducer. Second, distribution is almost equal. So now the reducers would produce the result as shown. Please note that single reducer outputs single sorted file, while two reducers outputs two individually sorted files. Another thing I want you to notice is that the word B has been processed by two different map functions, yet it is processed by the same reducer to produce the result. This has been only possible because of the shuffle and sort step in between, which is critical to any MapReduce solution. It is important to understand the keys are processed in a distributed fashion at map phase, and at reduce phase it is brought up together so that the processing of all the values to a particular key can be done by the same reducer. And all of this is possible because of the shuffle and sort steps. If you can understand this concept and break the problem to write map algorithm and reduce algorithm, then you can design MapReduce solutions. MapReduce can be written in many languages. In this course, we would see majorly the Java examples, but the point is to understand this concept and you would be able to apply it to any language. In Java, we would have to write three classes. First, map class, which would have map side of logic. Second, reduce class, which would have reduce side programming logic. Third is driver program, which will control and decide configuration and how the job would read and write the data. The functions like distribution of the code to multiple machines so that map gets the data locally and map output reaches the correct reduce machine along with shuffle and sort step in between. This is all is taken care by Hadoop itself, and programmer need not code anything for this. That is what makes Hadoop special. In the next lesson, let us look at the Java programs and see how it works.